complex numbers. So the first thing we're going to talk about with complex numbers are the imaginary numbers. So first with the imaginary numbers, we have I equals square root of -1. That's how it's defined. So anytime I see an I can think of it as a square root of -1. Now when I square that I, so the I squared, I'm just going to write out what that is. That's really -1 squared. And what happens with our square roots and squareds? They cancel each other out, and I should end up with a -1. Now that's something that's not proven, but that's the idea and the basis of why we say I squared equals -1. But like I said before, that's not something that's proven, so we just have to go for it this way. So when I see I squared, I get -1. Okay, with those two facts now, we can move on and talk about complex numbers. So it says here for complex numbers, if A and B are real numbers, then any of the form A plus BI is a complex number. In complex numbers, A plus BI, A is the real part and B is the imaginary part. So when we talk about these real numbers now, these complex numbers, the A is the real part and the B is the imaginary part. So that's something to keep in mind, because notice here when I have the A, if I didn't have anything for B here, then that would just be a real number. Or if I didn't have this piece here, that would just be an imaginary number. Okay, just like we had in the beginning, imaginary unit I. But together, it's a complex number, and we have a real and imaginary part. Okay, let's do some operations with these now. Okay, so this says, perform the indicated operation. Write each expression in standard form, A plus BI. So they call A plus BI standard form for these complex numbers. So what we're going to do first is we're going to add a number. So check this out, we're adding down here. Okay, so this says A minus 3I plus 4 plus 4I. So essentially how this works is it's no different than any algebra we've done previously, like with X's and all those other letters that we had. So addition is just what we think. So we really have 2 plus 4 and negative 3I plus positive 4I. So we get 2 plus 4, which is 6. And negative 3 plus 4, that's going to be plus 1I. But I'm just going to write I. So this would be the answer for that one. Hopefully that's okay with you. If not, get a hold of me. All right, now for the next one here. This one's a little different because this first complex number only has a real part. Okay, so this is really 2. And what I'm going to do for this second one, I'm not going to treat the minus like a minus. I'm going to distribute it through here, if that's okay with you. So this is really going to be minus 3 plus 12I. Because it's like I can put a 1 here and then distribute it through. That's the idea. So then I get this, 2 minus 3 plus 12I, and I can put these together because they're like terms. So that's kind of the idea here. So this is going to be minus 1 plus 12I. So there's our answer for this one. All right, now let's move on to the third one here. Now for this third one, this is multiplication. So keep in mind what we did here. So first we did an addition, then we did a subtraction. Now we're doing a multiplication here. Because I don't see anything between the 3 and the parenthesis, it means times. So this is just a simple distributive property I'm going to use here. So the answer for this one is 3 minus 12I. Okay, so that's the answer for that one. Now let's move on to D here. Now for D, this is a little bit more complicated than the previous problems because this is a multiplication here, since I don't see anything. and I have two binomials, algebraically, if I think of it that way. So this means I'm going to have to do a FOIL here. So what that means is I'm going to have to do 5 times 6, which is 30. And then I have here 5 times 2i, that's going to be 10i, and it's positive, so plus 10i. And then I'm going to do the third one here, that's this one. So negative 3i times 6, and they're different signs. So that's going to be a minus 18i. And then the last ones here, which is that, the negative 3 and the 2i, that's going to be negative 6i squared. Okay, now having this process here, I'm just going to simplify a little more. Now, normally I would just put the 10i and the 18i together because they're both i's, which is reasonable and correct. Another thing that's a little more difficult to see with these is, remember, I squared equals negative 1. So we can put a negative 1 there. So in simplifying this, remember, this is a times here, so it's going to be a 6 times a negative 1. So let's write that out now. So this is going to equal 30, and then that's going to be negative 8i. And then for the last one, it's going to be negative 6 times negative 1. And then to go a little further here, because now I have this negative 6 times negative 1, that's going to be a plus 6. And then I have this 30 over here. This is going to end up being a 36. And 36 minus 8i. That's what it's going to end up being. Definitely the longest problem we've had so far. Now for the last one, it's very similar to the one we just got done with. Now that may be hard to see, because some of you guys might say, oh, if I square it, that's just going to be 9, and that's going to be plus 16i squared, but it's not true. This is really 3 plus 4i times 3 plus 4i. So this is actually a FOIL here, just the same as the previous. So now what I'm going to do next is I'm going to multiply through here. I'll say distribute, same thing. So that's going to be 3 times 3, which is 9, and then 3 times 4i, which is plus 12i, and then 4i times 3, that's going to be plus 12i, and then the last one's going to be 16i squared, so plus 16i squared. So then to simplify this, we're going to do what we did last time. Now I know any I squareds I see that are negative 1s. And then I can put my 12i and 12i together. So this is going to be 9 plus 24i plus 16 times I. Negative 1, excuse me. Not I squared anymore. It's going to be negative 1. Okay. All right, so then I can write this as 9 plus 24i minus 16, and that's going to equal negative 7 plus 24i. Now keep in mind here, when I write my complex numbers, in general, you'll see the real part first and then the imaginary part. And also what you'll see too is there's a clear separation from the real part and the imaginary part. Now that might not be confusing now, but as we get into solving equations and using quadratic formula and things like that, where we'll have to be able to separate by plus or minus symbol between them. Okay, let's move on then. Actually, no, we'll end this video here.